Hello, time for episode 5. Yeah, episode 4 is a little bit wild because we started to talk about building a program representation, which we did with a bunch of little helper functions to build objects for it. And then we worked them into the analyzer using an OHM semantics object and added a representation. We found that semantic analysis and building a program representation is rather involved. There's a lot that goes on. So we went through some of the basics on how you take each element of interest in your OHM grammar, and based on the right-hand side of each grammar rule, you send them in as parameters. Then you try to build a piece of the program representation. But in the last video, we realized that, hey, we haven't really gone very far. We don't even know if any of this stuff works. And that's what we want to do right now. You can see right now there's a number of issues that I'm surprised that VS Code is even picking up. Made use of a heck of a lot of things from the core module that hasn't even been used here. I mean, okay, at least Copilot seems to know how to be able to do it. So Copilot's bringing in a number of different items from the core module. That's the first thing we need to do. But what we really need to do, what's really, really important over here, is to get some tests built. Right now, we only have a parser test, and well, this compiler test has a lot to do later, but we built up a test for the parser. Let's get an analyzer test built in here. Let's touch test analyzer test.js. And inside of analyzer tests, let's create some, let's just say describe the analyzer. What should the analyzer do? Well, if we need to do a lot of different things, but the first thing we need to do is analyze a simple program. So analyzes okay, let's see what Copilot wants over here, single variable declaration. Okay, let's see what this looks like. Okay, so no, we're actually using asserts over here. Assert dot deep. Well, you know what? You gotta keep these IDs happy by doing your asserts first. From, can I just say import assert from, sorry about this, assert strict, and say node over here. And then what we can do is we can say assert deep equal. All right, there we go. Okay, got some issues over here. Got to close stuff up properly. That didn't work. All right, well, anyway, here's what it's trying to do. It analyzes, it should close with, dang. Here, let me pause and clean this up. All right, I cleaned stuff up over here. We're taking let x equals 1, and we want this to be a program with a list of statements. The first one is a variable declaration where the variable is x. And right now, we're not even taking care of types, and the initializer is 1. And we just want to make sure that when we analyze the source program, no, it's analyze of parse of source, we get back what's expected. So this is the test we want. If we do npm test analyzer test.js, probably we're going to get lots of failures. And we do fail. And what does it say here? Analyze is not defined. Well, that's an easy one to fix. Import analyze from analyzer, source.analyzer, although sometimes Copilot will forget the .js, which is usually something you want to have. Okay, cannot find core from analyzer. Okay, so when we're inside of analyzer, see what I was saying earlier? Doesn't like that JS, that's very important. Okay. All right, parse is not defined. Let's fix that. Programming can be so fun. Well, at least I got Copilot here. All right, now we're getting there. Cannot access variable before initialization at Vardek. Okay, so this is an error that we're getting from OHM. that's, or not, it's not from Ohm, it's from JavaScript over here, but it doesn't like how we did statement var dec in our analyzer on line 25. Okay, now we probably didn't, oh, we did import a variable from, oh, yeah, can't do that. Can't use variable twice over here. So this is, I guess, this is the new variable. The new variable. Ha. We have to find the good names for everything over here. Okay, that wasn't quite equal. So what actually happened over here? You kind of got to read through here and see what the problem is. So apparently we're getting a bunch of undefined statements. Our variable declaration didn't get returned, right? Because we were hoping to have this as the first statement, and instead we ended up with the big fat undefined. So we go back here to try to find out what's wrong over here. Statements, children, map, S goes to S rep. See if we can work through why that's failing. And what you notice, we picked the one thing where we forgot to put in that return statement. That we actually have to return something from the var dec. So you should make sure that each one of these things has a return. It's an error which could occur at any time. Okay, so running this, okay, we're closer, but variable declaration is not defined. Let's add it and test again. And there we go. Okay, so we have this one test passes, which is good. We can actually make this a little bit more involved. Let's do one that's, let's put like a little print over here and try, yeah, let's just try printing X, I suppose. And so our second statement over here will be an assignment, a print statement where we're printing the variable named X. And let's see how that works. And syntax error, of course. Okay, prettier did not do its thing, so. All right, oh, not quite, because when we printed, okay, so when we're printing, we're trying to print this variable. That's exactly, this is now leading to the part where we have to do actual semantic analysis. So rather than getting a little far ahead, let's just make sure that we could, for example, print 2. Before we get ahead of ourselves, let's try and print 2 and make sure that test passes, which it does. Analyzes a, let's clean this up, analyzes a simple program that basically doesn't have any variables in it. Let's make sure that works. And we're good. Okay, now let's try to deal with the complexities of printing something like X. Okay, what actually should we see? Well, we should see that this is indeed a variable whose name is X. Not only that, it needs to be the same X variable that we defined here. So now we're starting to get into the difficulties of really doing semantic analysis, type checking and stuff like that. Whenever you declare a variable, we need to store it somewhere, right? And whenever we reference a variable, like if this were to say print Y, well, that's grammatically correct, that's syntactically correct, but that Y is not previously been declared. We probably want that to be an error. So we now are getting ourselves into a part of the analyzer where we have to do just a heck of a lot of thinking. So where do we even start? That'd be a thing to do. Well, I would say the following. If you see a variable declaration and you create a variable, you need to remember that variable. You need to store it somewhere. You also have to do the type checking. You have to make sure that you figure out the type of this expression and then the variable is stored with that, because later you want to make use of that information. For example, if I know x is an integer here, then it would be okay for me to say this, x plus 3. But if x were started off to be something like dog, then I should not be able to, well, I have to write it like that, obviously. But I would not be able to add, because you cannot add strings to numbers. I mean, that's kind of ridiculous. So we have, not only do we have to record the fact that a variable was declared, but also what the type of the variable was. It's probably good to, let's start with storing the, it's probably good to start with storing the variable. So let's do that. How do we store the variable? Well, a simple approach is to create in your analyzer an object called a context. So let's over here say, let's create a context object, and a context is where we're going to store all of the variables, right? So I'm just going to say, I'm going to make a new context object. But what's a context object? Context objects are where you actually store things, okay? So let's create one over here. Let's make a context object. Sorry, let's make a context class. And in our context, we'll store local variables in a map. And that's good for now. Also, we should also, when we create context objects, we're going to have nested functions in this language, in COT. So in COT, you can have a function inside of another function, or you can declare variables in the block of a while statement. So the local variables in an inner block are great. They're separate from the ones in the outer block. So we can make something called the parent context. And let's just say that the parent context is something that we'll pass that in. So let's just actually specify the parent here as null as the default. And let's make sure we didn't break anything, because every time we type something in, something could go wrong. Okay, cannot read something from parent because I didn't pass anything in. So, oh, you know what I need to do? Yeah, we need to default this. I need a default on that. See, always good to keep your tests running. Make sure you don't break stuff as you go. All right. Yes, I expected this test to fail because we're trying to make it pass. So that's the context. When you see a variable declaration, what you want to do after you create this variable is you want to add it into your context. So we want to say something like here is we want to say current context, we want to add this local variable in. So it's going to have this name, ID source string, and we're going to add in the new variable. I think that's probably the best and simplest approach to do, is to assume that we have an add function on the context with the source string of the variable. So let's make sure we have an add method here. And we'll add in whatever the name is, and then whatever the entity. Entity is the thing we're storing. It's the variable or the function or whatever. And then we'll put it into the locals. I'm going to call this actually locals because I like that name. I like that name a little bit better. And that's going to be our approach to adding things to the context. We should also be able to look things up. So when a variable is stored, you want to do a lookup on it. So let's look up the name. And well, it's trying to be a little bit fancy over here and throw an error if it's not there. Rather than throwing an error, sometimes you want to look something up in the context and you don't want it to be there. So I'm going to write this in a different way. I'm going to say return a, oh, what does this want? This locals.get name. This is promising. Let's see. Yeah, so try to look it up in the locals map. Okay. And if it's not there, then go look it up in the parent, and the parent might be null. So yeah, that's actually what I was going to do. Copilot is actually pretty nice. So we're not going to worry about nested context yet, but this will be a good start. So what we have right now is we got our initializer, and then we have make a new variable. I don't have any type checking done yet. So we're going to do that later, but I just want to make sure that we can store a variable and then look it up. So I'm going to store this thing here. Now this means that whenever we want to look up a variable, we want to see if it's present or not. And this happens when we look here, right? So the idea is when you're trying to get a variable, don't just look it up, right? We need to do a little bit more. I'm sorry, don't just return. We actually have to look it up. So let's do this. Let's do the lookup from the current context. There it is. And then we can return the entity that we found. So if things have gone well, then in our test where we are trying to put in X and print X, I'm hoping this will be close to passing right now, if not straight up passing. Oh, it actually did work. Now notice that if I try to do print Y right here, let's see what will happen. So the test breaks because we could not actually find that value. We couldn't, there was no Y in the context. In fact, it was an error, but we didn't actually throw an error here. So what we need to do is make sure that if this thing is not found, something like if the entity is not found, we want to throw an error like this. Now the test will break and it will say, oh yeah, you actually threw an error here. And the error that you threw was undefined variable Y. This means that we can fix our test up a little bit. We can accept this test, and then we can write another test. So we can say something like it throws an error for an undefined variable. So we'll try to get print X, and then it should say something like undefined variable Y, capital U. No, actually, yeah, it's going to be X here. So let's see if we can get this test to pass. And what did I do wrong here? I'm going to blame Copilot for that mistake. And so we're doing our analysis, and yeah, both tests passed. So we're actually able to throw an error if the variable was not found, which is woohoo! That's actually great. We can do a little bit better though, and what I would like to do is actually, before I do more on the test, let's see how we can wire this into our main compiler like we started to do before. I was going to return here the program representation over here. So let's actually, in our example, we have our hello example. Let's do our print X example. So print X dot colon. This is one where we said let X equal 1 and then print X. So let's see what happens right now when we try this. So node src cut.js examples printx.cut. And we saw earlier that we can parse things, and that works. Now let's see if we got analyze to work. And their analyze is actually giving us a picture, which is, it doesn't actually print all that deeply, but it does work. And by the way, remember if I change this to Y, it starts saying, woo, undefined variable Y. Now, I got to do two things before I wrap up this video and start doing, more and more semantic analysis. Right now, I'm just interested in wiring this into the compiler. I want to get this error message to look really good, because you know what Ohm is really good at? In Ohm, if you have a syntax error, like I'm missing the right parenthesis here, Ohm is really good about this. When you have a syntax error, Ohm will tell you the line number, the column number, give you a little arrow over here and tell you what's wrong. This is very nice. But for semantic errors, static semantic errors, it doesn't do that. It's just showing you this. So a good question to ask is there a nice way where we can get Ohm to display something like this for semantic errors? And it turns out there is, and it's really kind of cool to do. So let me show you a good way to do that. I'm going to write a little function out here, which I'm going to call must. So it's like a little assertion checker, and you give it a condition that you want to hold, and then you give it a message, and then you tell it which token you want to show the error at. And then you use the ohms source dot line and column message to print that cool thing out. And then I'll have some room here for a leading message. Okay, so I'm going to do this little prefix here, line and column message, and then I'm going to write out what the actual error message was. And then when I do that, I can do, I'm going to do this. I'm going to clean this thing up a little bit. In my analyzer, I'm going to write a little helper function here called must have been found. So that's going to check that the identifier that we're looking for actually was found. So when we look up identifiers down here, I can say, rather than this, I'm just going to say must have been found. And I'm going to say, all right, you go into the context, you look up this ID and you look for it. And if it's not there, it's going to return undefined. And undefined is not truthy. So this will fail. And then, so what it's going to do is it's going to take ID source string, embed that into the message. And then the ID is going to be the part where you actually show the error message out. But actually, you know what I did? I just remembered that I like doing this thing. I like making an at property over here because it means that the error messages can look kind of cool. It's kind of hard to read this way. So whenever you have a chance, try passing in objects and destructuring so that when you make your calls, you say, okay, entity here, and then you say at. So I do this message. So I have the, let's see how this works. If I save that, I'm going to go over here and I'm going to run this breaking program again. And now you can see identifier Y not declared. This is the error message that I wanted. And I actually have a pointer right here. This at ID, this is the offending ID. And now my semantic errors look just like ohm syntax errors. So a very nice thing to try. And with that, I will call this the good place to stop on getting semantic analysis off the ground. Yes, we still have a lot more semantic analysis to do, including all the type checking. That's coming up in the next one. See you there.